let me take you through a little video now of how the virus chip works. So again, it's a solid substrate of glass, and on that glass we've printed or deposited lots of DNA in little teeny spots. So there's the little spots, obviously not to scale. Some of these spots might represent SARS, for example, just highlighting them here. Some of those spots might represent sequences from dengue. There's no order to the spots on the array. And if we zoom in, obviously not to scale, you can see little DNA molecules stuck to the glass. And these were deposited using robotic printers of our design and production in my lab. Now, a sample is applied to the chip. Come take a fantastic voyage with me now, as we then drop onto this chip sort of Roadrunner style. And this sequence, yeah, you know what's going to happen. These sequences that are labeled with fluorescent dyes will then be allowed to hybridize to the sequences that are on there. So here's this complex mixture of nucleic acid. A lot of it's not virus, a lot of it's host, only some of it's virus, and this is a virus spot. And one sequence finds its match, the complementary base pairs, hybridization occurs, and by virtue of hydrogen bonding and energy, that sequence stays there. Again, another sequence touches down, and another, and so on. Finally, the last step of this process is to just wash away all this material that doesn't belong. And we're left with the good stuff, the fluorescent label stuff. And then a giant laser beam, it's really small actually, but it looks giant here, comes zooming by and illuminates the fluorescent dyes that are stuck to this nucleic acid. And that allows us to visualize which spots had hybridized material to them. And so we zoom out for the array, well, we should see some complex pattern of spots that are lighting up with fluorescent dyes that indicate what was in the sample. Now, you're going to have an opportunity, for those of you that signed up in the bioinformatics exercise, to take data from real patient samples of actually infected individuals and analyze the raw data from these chips. And your goal in that bioinformatics exercise is to tell me what virus was afflicting those individuals. And it's going to be exactly what you do if you were a graduate student in my lab. I'm not going to pull any punches.